look at those two problems. Let's see. 5. Okay, so for number 5, we were told we got the portion of plane that y plus 2z equals 2, and the cylinder is defined as x squared plus y squared equals 1. Okay, so, and we asked to find the area. All right, so we can use the use cylindrical coordinates. So we can say that x is equal to r cosine of theta. We can say that y is equal to r sine of theta. And we can say that z will be equal to, let's see here, say 1/2 times 2 minus r sine theta. Okay. So, oops. We can say r of r theta is equal to r cosine of theta plus r sine theta plus basically 1 minus 1/2 r sine theta. And this is the I, J, and this is K. Okay, so if we do the partial in respect to r, we're going to have minus 1/2 sine theta K. Okay. If we do the partial in respect to r, so you got number 5 to work? Okay, so do you need me to finish going through it? Okay, so what do we have? Our theta should be negative r sine theta I plus r cosine of theta in the j. And then this is going to be minus 1/2 r cosine of theta in the j. Okay. So if we look at the cross product, okay, so we'll have cosine of theta, sine theta, negative 1/2 sine theta. And then the second one, we're going to have negative r sine theta, r cosine of theta, negative 1/2 r sine of theta. So for the ith, we're going to end up with so we're going to have 0 in the ith direction. For the j, we're going to have minus, let's see here, negative 1/2 r cosine squared theta. Actually, it's going to be minus 1/2 r sine squared theta. And that's in the j direction, plus the k. We're going to have, it's going to end up being just r in the k direction. So really what we have is 0 in the I. We're going to end up plus 1/2 r in the j plus r in the k. So if we look at the magnitude of this, so we're going to have square root of 0 plus 1/4 r squared plus r squared. So the square root of 5/4 r squared, or square root of 5 over 2r. Okay. So now if we look at this, r is going to be bounded between 0 and 1. Theta is going to be bounded between 0 and 2 pi. So if we set this up, we have the double integral of the square root of 5 over 2r dr d theta. So from 0 to 1 and from 0 to 2 pi. And then this should work out nicely. So 0 to 2 pi, square root of 5 over 4 r squared from 0 to 1. So we're going to have 0 to 2 pi. Basically, we're just going to end up with the square root of 5 over 4 d theta, square root of 5 over 4 times theta from 0 to 2 pi. So we're going to end up with square root of 5 pi over 2. I think that's what the answer should be. Okay. Any questions? Okay, so let's look at number 6. So we're doing the portion of the cone. Okay, so we have that z is equal to 2 times the square root of x squared plus y squared. Z is between z equals 2 and z equals 6. Correct, yeah. Okay, so again, cylindrical coordinates are probably going to be the best. So we're going to have that x is equal to r cosine of theta, y is equal to r sine of theta, z will be equal to 2r. Okay, so r of u theta will be r cosine of theta in ith direction plus r sine of theta in the j plus 2r in the k. So if I take the partial with respect to r, so I'm going to end up with cosine of theta in I, sine theta in the j, plus 2 in the k. Partial in respect to theta, so negative r sine theta in I plus r cosine theta in the j plus 0 in the k. Now we know that r will be bounded between 1 and 3, and theta will be bounded between 0 and 2 pi. Okay, so if we look at the cross product over I, jk, so we have cosine of theta, negative r sine theta, r cosine of theta, 2 and 0. So for the ith component, we're going to end up with 2r, negative 2r cosine of theta in the I direction. For the j component, we're going to end up with minus 2r sine of theta in the j component. And then for the k component, we're going to end up with just plus r in the k direction. So, any questions so far? So for our magnitude, we're going to end up with the square root of, so we're going to have 4r squared cosine squared theta plus 4r squared sine squared theta plus r squared. So we should end up with the square root of 5r squared, which is the square root of 5 times r. So for our surface area, it's going to be the double integral of the square root of 5r dr d theta. We said r runs from 1 to 3, theta from 0 to 2 pi. So if we integrate the first time, we should get the square root of 5 over 2 r squared from 1 to 3 d theta. So if we evaluate, we're going to have basically 8 times this, so that's going to give us 4 times the square root of 5. We're going to integrate from 0 to 2 pi d theta. So we get 4 square root of 5 theta, evaluated from 0 to 2 pi. So we should get 8 pi square root of 5 for our answer. Any questions? No problem. There's really no rhyme or reason. Sometimes it's just easier to stay with in terms of x and y. Um, and sometimes it's easier to switch into r and theta. So in kind of the look of it in terms of doing the problem, if you cannot get things in terms of two variables, then switching over to r and theta is the easiest thing to do. So if it's in terms of x, y, if it's in terms of say x and y, and you can get everything and write all your different pieces in terms of x and y, then it's fine because your r function needs to be in terms of two variables and not three. But if you don't really see there's an easy way to do it, you can always switch it over to the corresponding polar or cylindrical or spherical. Okay, no problem. All right. All right, so let's look at problem number 7. Let's see what we got going on here. So we're dealing with the portion cylinder, x squared plus y squared equals 1. And then we've got the plane z equals 1, and z equals 4. So we have x squared plus y squared equals 1, z equals 1, and z equals 4. Okay, so in the case of this, I'll just define everything in terms of what they are. So we can say that x is going to be um, Okay, so this is an example where we're not going to want to switch over to, say, cylindrical, because we really don't have a clear way of defining C. Okay, so we can say that x is x, y can be defined as the square root of 1 minus x squared, and we can say that z is z. Okay, so we can write an r of xz, and we've defined as x in the I direction plus the square root of 1 minus x squared in the j plus z in the k. So we do the partial with respect to x. We got 1 in the I minus 2, no 2, sorry, minus x over the square root of 1 minus x squared in the j plus 0 in the k. And if we take the partial with respect to z, 0 in the I plus 0 in the j plus 1 in the k. Now, we know that z is bounded between 1 and 4. X will be bounded between -1 and 1. Okay? So if we do the cross product, so we have I, J, K. Let's see here. We're going to have 1 negative x over the square root of 1 minus x squared, 0, 0, 0, 1. So if we look at the I component, we're going to get negative x over the square root of 1 minus x squared in the I direction. For the j component, we're going to get minus just 1j, and in the k component, we're going to get 0. Okay. All right, so next, we'll take a look at the magnitude. All right, any questions so far?
So like when it comes to like problems like this, do we always make x equals x and like c equals c?
Normally I would, if you wanted to do things in terms of y and z, that would be fine. But normally the first one, I always just rename it as itself, and
Oh,
then
okay.
try to do the next variable and for the next variable, if I can write it in terms of the previous, then I do that.
Oh, okay. Makes sense.
Mhm. Yeah, I try not to overthink it or make it hard. So if I say that the first variable is going to be itself, then I know that somewhere later that I can be able to define another variable in terms of that first variable or maybe the last variable. Okay, because if this was x squared plus z squared equals 1, then I would have said the first one was x, the second one was y, the last one would have been the square root of 1 minus x squared. And I would have wrote a equation in terms of x and y. Okay, so next I'm going to look at the magnitude. So I'm going to have the square root of x squared over, going to be 1 minus x squared plus 1. So if I take a look at this, make sure that's right. Yes. So what I'm going to do is get a common denominator. So I'm going to have the square root of 1 x squared plus 1 minus x squared over 1 minus x squared. So really I'm doing the square root of 1 over 1 minus x squared. Okay, that's what it ends up being. Okay, so we're going to do our double integral of 1 over the square root of 1 minus x squared. Let's do dx. z. Now, we said that x runs from -1 to 1. We said that z runs from, I think it's from 1 to 4. Okay. All right. So if I take the antiderivative of this, it's going to be the integral from 1 to 4. And we're going to end up with the sine inverse of x, evaluated from -1 to 1 dx. Okay. All right. So we're going to have the integral from 1 to 4. Sine inverse of 1 is going to give us pi over 2, minus sine inverse of -1 is negative pi over 2 d theta. So I have the integral from 1 to 4 of pi d theta. So if I hold on. I feel as though I'm leaving something out. And what did I leave out? Hold on. Oops. Let me go back one screen. So Z is going to be 1 to 4. This has to be for. This is going to be 1/2 times 1 minus x squared to the -1/2 times -2x. So it should just give us -x. It's not, there should not be a 2. Yeah, because I'm going to get 4 pi minus pi, which is 3 pi. But it's 2 times as big, so it should be 6 pi. I see why. Here's the catch. Okay. Keep in mind that if I solve for y here, it should be plus or minus, but I'm only looking at the plus side. So I have a whole nother half to deal with it. So I'm only going to find the surface area for half. So what I need to do is to multiply my final answer by 2. So I need to multiply this by 2 so I can get both halves. That's why. I knew it was something small. Okay, and you'll get 6 pi. So even though I didn't switch it over to the U and V the way I put the answer there, you still get the same answer. I got from -1 to 1 because if I said that y is 0, what are the values for x? X has to be bounded between -1 and 1. Okay. All right. Any other questions? Okay, so let's look at our last example. Okay. All right, so our last example that we're looking at is that we are told that f is equal to y squared in the I direction plus xz, in the j minus 1 in the k. Outward, normally away from the z-axis through the cone of z equals 2 times the square root of x squared plus y squared, where z is bounded between 0 and 2. So in this problem, we are basically asking to find we're asked to find the flux. Okay, so we're asked to find the flux. So if we take a look at this, probably the easiest thing to deal with, since we're working over the cone, it's going to be working with parametric. Okay, so we're going to say, I mean, not parametric, in cylindrical coordinates. So we're going to say that x is equal to r cosine of theta. We can say that y is r sine of theta. So what would z be equal to? So what would z be equal to? Yeah, z will be 2r. Okay, so our parametric equation will be r of r theta will be r, yes, cosine of theta. And let me see, theta, let's do that real quick, sorry. Theta will be bounded between 0 and 2 pi. Now r is going to be bounded between what and what? Does it say that y is between? Let me look at that. It should be, I think it's a typo on my part. I'm 100% sure. No, it should be that z is between 0 and 2 pi. It's a typo on the form, on the notes. Okay. And yeah, and r is going to be between 0 and 1. Okay. R is going to be between 0 and 1. So do make sure you change that on the notes. It should be z and not y, between 0 and 2. Okay. All right. So our parametric form will be r cosine of theta in the I direction plus r sine of theta in the j plus 2r in the k. So the partial with respect to r, cosine of theta in the I plus sine theta in the j plus 2 in the k. Partial with respect to theta, negative r sine theta in the I plus r cosine theta in the j plus 0 in the k. Any questions there? All right, so if we look at the cross product, so we're going to end up with negative 2r cosine of theta in the I minus 2r sine theta in the j plus 2, excuse me, not 2, but just r in the k. Okay, so in order for us to do this, basically what we're going to be looking at is we're going to be doing first, let's deal with f. Okay, so f was defined as y squared in the I plus xz in the j minus k. Okay, so one of the first things we need to do is to transform that function in terms of r and theta. Okay, all right, so in place of y, we're going to put in r cosine, excuse me, not r cosine, r sine of theta. Plus, in place of x, we're going to have r cosine of theta. In place of z, we're going to have 2r and minus k. Okay. All right. So we're basically going to be looking at the dot product of f and the partial of r in respect to r crossed with the partial of r in respect to theta. We're going to be dotting those two. So we're going to have r sine theta, comma, 2r squared cosine theta, comma, negative 1. And we're going to dot that with 2r cosine theta, 2r sine theta, and negative r. Okay, so we're going to do the dot product of those two. All right. Isn't the r... for the, oops, hold on.
For the, when we converted it to r theta, isn't like y squared, so it would be r squared sine squared.
Oh, thank you.
Yeah.
Okay, that makes sense. It's like, okay.
And also for the n, how did you get those those sign the other way, the opposite way. Like you got -2r cosine theta in the previous when we saw for the
Okay.
cross product. Oh, okay.
Because and you have to remember back when we talked about cross products, if you do R switch the cross product around, then it's the negative of the other. And the way I've got it worked in my notes, I have it as R theta cross R. So that's why I have the signs backwards. But I've got it fixed so they match to what I have. Okay, so if I multiply these two together, I'm going to end up with, let's see here, -2r cubed sine squared theta cosine theta minus 4r cubed sine theta cosine theta minus r. Okay, so I'm going to do the double integral, okay, of -2r cubed sine squared theta cosine theta minus 4r cubed sine theta cosine theta minus r. And we're going to integrate in respect to dr d theta. All right. And we're going to integrate in respect 0 to 1, 0 to 2 pi. Okay. Because we said that r was bounded between 0 and 1, thetas were bounded between 0 and 2 pi. Okay, so if we take a look at this, we're going to have the integral from 0 to 2 pi. So we're going to integrate in respect to r first. So we're going to end up with -1/2 r to the 4th sine squared theta cosine theta minus r to the 4th sine theta cosine theta minus 1/2 r squared from 0 to 1 d theta. Okay. All right, so if I take a look at this, I'm going to evaluate it at 1. I don't have to worry about 0, because if I put in 0, I'm going to get 0. So if I plug in 1, this is what I'm going to have. So I'm going to have the integral from 0 to 2 pi. So I'm going to have -1/2 sine squared theta cosine theta minus sine theta cosine theta, and then minus 1/2 and d theta. Okay. All right, so if I integrate this, the first two pieces will be just a u sub. We can let u be sine of theta, so the du will be cosine of theta. So the antiderivative of the first piece is going to end up being -1/6 sine cubed theta minus the second piece is going to end up being -1/2 sine squared theta minus 1/2 theta. And we're going from 0 to 2 pi. If we plug in 0, everywhere it's going to be 0. If we plug in 2 pi, we're going to have 0 plus 0 minus 1/2 times 2 pi. So we're going to end up with -pi. Okay. but let's be cautious. Okay. So typically when we do the flux, okay, the flux is based on the fact that we are going to be going um, so we'll be going normal across the x line. So yeah, number there's our flux. Any questions? Okay. All right. Well, that is the last example that we have. Okay. So that's basically all the material that we have for the course. Are there any questions? Okay, so just a couple of reminders. One, don't forget about quiz 12 20 that is um, due on Thursday. On Thursday, I'll answer any questions you have over the last homework assignment since you don't have a quiz on it. But it will be material that you require as far as the exam is concerned. Your final exam does open on, uh, remember, I think I have it opening on Thursday. The exam will open on Friday and will be due on Tuesday. So you'll have all day Friday, Saturday, Sunday, all day Monday, and it's due Tuesday, 11:59 p.m. So you'll have 5 days to complete the exam. Okay. Any questions? No, it's not timed. There's no way you can complete 15 problems in a 3-hour period. Okay. Now, one of the things I will tell you is to make sure that you follow what the directions ask. So if I'm only asking you to set up a problem, that's it. Don't try to integrate it because that's not what I'm asking for. So just make sure you pay attention to that. Also, do make sure, just like the quizzes, you need to make sure you show your work. If you don't show your work, I'm not going to give you full credit for it. Okay? Any questions? All right, well, that is it for today. Again, on Thursday, I'll just be answering any questions you have. Pretty much the way things are outlined for the breakup of the materials from the midterm and the final. What I started with on the final, that is the material that is that we're going to be focusing on as far as the final exam is concerned. It's not over everything. There's no way that I'm going to put everything on there. But if you notice in the second half of material for this course, the majority of it dealt with integration. So the majority of the final will be dealing with integration. Okay. Any questions? All right. You guys have a great rest of the day, and I'll see you on Thursday to answer any last minute questions that you have. Okay.